Hello everyone, welcome to aptdemy. Myself Dr. Nandita, and today we will solve some mathematical problems on the concept of thermodynamics. So these are some important mathematical expressions. You can have a look and also in this slide too. Now let's start to solve some problems. So problem 1 is asking the entropy change for vaporization of a liquid is 109.3 joule per Kelvin per mole. The molar heat of vaporization of that liquid is 40.77 kilojoule per mole, and they are asking to calculate the boiling point of that liquid. Now let's start to solve this problem. So what are the information that are given? So it is given that entropy change for vaporization that is delta S is equal to 109.3 joule per Kelvin per mole, and molar heat of vaporization of water is 40.77 kilojoule per mole. Right? These are the informations that are given in this problem. Now, what do you know from the entropy change? So what is the formula that we are going to use here? That delta S is equal to Q reversible divided by T, right? And now this T will consider as the boiling point or boiling temperature. So the T, or you can write boiling point from the equation that we know can be written as Q reversible divided by delta S, right? So we'll just put the values. So the T then will come out as 40.77 times 1000 divided by 109.3, and then if you solve, the boiling point will come out as 373 Kelvin. Okay, so very simple. If you know the formula, then you'll be able to solve this problem very easily. Let's move on to the next one. So problem 2 is asking, based on entropy change, predict a spontaneous reaction among the following. Two reactions are given and we have to predict which of the two is spontaneous, right? So what do we know about entropy? Entropy is a measure of disorderedness, right? And we also know that, so entropy is the degree of disorderedness or randomness, right? And we also know that this entropy for gaseous molecules is the greatest, right? Because gas molecules are moving around all the time, so disorderedness or randomness are much more for gas and than liquid, for example, and disorderedness in liquid is again greater than solid because solid particles are closely packed. So disorderedness for solid is least among the states of the matter, right? So here if you look at the equation, you can see that from 2 moles of gaseous ammonia, right, 1 mole of, sorry, here you can consider as 1. So if you check that there is no gaseous substance in the reactant side, whereas in product side you can check that 2 plus 1, that is 3 moles of gaseous molecules are generated due to this, the reaction, right? So we can obviously say that this is a spontaneous process, and disorderedness here would be much more greater because we are generating 3 moles of gaseous molecules from 1 mole of solid substance. So disorderedness or randomness would be much more here than here, where you can say the product is solid. So randomness is much more less here than here. So we are generating solid product, so randomness is very low. So in terms of spontaneity, what can we say? That option A or the equation A is spontaneous, whereas equation B is non-spontaneous. Or sorry, randomness here or entropy here is positive. Entropy is much more higher for equation A than here in equation B, because solid product is produced, right? So very simple. So this one is having much more randomness, and that's why it is spontaneous, right? Very simple. Now problem 3 is asking calculate delta G0 for the following reaction. So this reaction is given here. You can say, right? So and some other information is also given, that delta G0 of Cu2 plus aqueous is 65 kJ per mole, and delta G0 of Zn2 plus aqueous is minus 147.2 kJ per mole. So yeah, so we have to calculate the delta G0 for the following given reaction, right? So what we know, that standard free energy, we have to write the expression, right? What can we write? So standard free energy change for the given reaction can be written as delta G0 sum over delta Z F0 for products minus summation delta G 0 F for reactants. This is the formula that you need to keep in your mind in order to solve such problems, right? So we'll just put the values. So delta G0 can be written as 147.2 plus 0. If you check the product part here, it is in solid form, so delta G0 must be 0 for this one, and this value is given. We have put the value, right? And for, if you check the product side again here, so this is delta G0 for this part is also again 0. So we'll just write for reactant part, that is this part, this would come out as this is 0 and this value is also given. So we'll put the value here. So 0 for Zn in solid form and 65 for Cu2 plus is given. So if you finally solve, you will get minus 212.2 kilojoule per mole. So delta Z0 for the given reaction is minus 212.2 kilojoule per mole. Now let's move on to the next problem. Problem 4 is saying the equilibrium constant of a reaction is 73. Calculate the standard free energy change. So for this, equilibrium constant value is given as 73. So what we know that equilibrium constant K is related to delta Z0 via the following equation. So what is the equation? That delta Z0 is equal to minus 2.303 RT log K. Right? We are writing here in terms of log. Now if you substitute the values of K, which is given as 73, that is the equilibrium constant, the temperature is 298 Kelvin, and R we know that 8.314 joule per Kelvin per mole. So then delta Z0 can be written as minus from this equation as minus 2.303, R is your 8.314 and 298 is the temperature and log 73, that is log K. So if you solve, you will get minus 10.632 joule per mole. The delta G0 has been come out as minus 10.632 joule per mole, right? Problem 5 is asking the following reaction is spontaneous. So a problem or a reaction has been given in this problem, that is H2 plus half O2 giving you H2O. And what are the parameters given? Delta S0 is given as minus 163.1 joule per mole per Kelvin. The absolute entropies of H2 and O2 gas are also given as 130.6 joule per Kelvin per mole and 205 joule per Kelvin per mole respectively, and they are asking to calculate the absolute entropy of water. So let's write the equation once more. H2 gas plus half O2 gas is giving you 1 mole of H2O in liquid form, right? So what can we write for change in standard entropy? We can write that delta S0 is equal to delta S0 H2O liquid minus, that is from the product side of this equation, and now we'll write the from the reactant side, that is S0 H2 plus half S0 O2. This is from product side and this is from reactant side. Now, delta S0 is given as 163.1 joule per mole per Kelvin, and delta S0 H2 should be calculated, and the other values are also given, that is delta S0 H2 has been given as 130.6, that is given here, and for delta S0O2 it is also given as 205, and here we have a half from this equation, so we'll just put a 2 below. So these are the values which are given. So now if you calculate for this particular one which has been asked to solve in this problem, this delta S0 H2O liquid has been come out as 69.9 joule per Kelvin per mole. So the absolute entropy change of water is the following, that is 69.9 joule per Kelvin per mole. I hope you have enjoyed this video. For more such updates, you can go and check and visit our aptdemy LMS platform. Thank you very much for listening. Thank you so much.